So we will see Newton's interpolation formula, Newton's forward interpolation formula and Newton's backward interpolation formula. I had told you, if we have a table for which we have values of x, let's say x0, then x0 plus h, then x0 plus 2h, that is, they have equal intervals between them. If we have this type of table where we have yx and then value of y corresponding to x, if we have this type of table and we want to know what is the value of x, let's say this one, in between this and this. So for value of x in between this, what is the corresponding value of y? Let's say this is xn, so xn, yn, what is yn? If we want to know this, or we have this thing, we want for xn equal to yn. So what are the values of y corresponding to any value of x that is not in the table? Let me explain this by giving numbers. Let's say this is 2, this is 4, 6 and 8, and the corresponding values are 10, 20, 30 and 40. Now if I want to know what is the value of y for x equal to 3, or I want to know what is the value of y at x equal to 9 or 7. So this is called interpolation. If we have to find the values of y for any value of x that is to the upper end of the table, this side, we use Newton's forward interpolation formula. And if we have values of x to the end of the table, this side of the table, then we use Newton's backward interpolation formula. This you should keep in mind. Now let's see what is the formula and how we actually come to that formula. Forward interpolation formula first. See what we have. Let's say we have to find x, the value of y at x equal to x0 plus some number ph. We have x0 plus h, x0 plus 2h, x0 plus 3h and all. Let's say we have to find at x0 plus ph. The value between two given values is x0 plus ph. From here what we get, p is equal to p is x minus x0 by h. So p is a real number. Then we can say that yp is equal to function of x0 plus ph. Okay, because this is the relation between x and y, or this can be written as e to the power p fx0. But we know that p e is given as 1 plus delta. So this is this function, or I can write, instead of fx0 I can write y0. Clear? Now if we expand this by binomial's theorem, what we'll get? We'll get yp, that is fx0 plus ph. This can be given as, we expand 1 plus delta term. So what we get? We get 1 plus p delta plus p into p minus 1 by factorial 2 delta square plus p into p minus 1 into p minus 2 by factorial 3 delta cube and so on into y0. Okay, this is the expansion of that particular term, 1 plus delta to the power p, by binomial's theorem. Okay, or we can put it here. So this is y0 plus p delta y0 plus p into p minus 1 by factorial 2 delta square y0. Third term, p into p minus 1 into p minus 2. I am writing up to the third term. So this goes on. This is Newton's forward interpolation formula. Very shortly we will be seeing some examples and we will understand how we actually find it. But you should learn this, you should note this formula in your copy and learn by heart. So this is Newton's forward interpolation formula. Let's see Newton's backward interpolation formula. As we did in the last section, Newton's forward interpolation formula, here what we'll have instead of x0, because we are having value to the last of the table, you can say it is the nth term. So this will be xn plus ph, similar to what we did there. From here p will be equal to x minus xn by h. Okay, this is very similar to that, and we know that the pth term is actually equal to this xn plus ph, whatever be the nth term. So it is, from there we have this p, so this is equal to e to the power p into what? This is function of this, function of xn, or we can write epyn. This function of xn is yn. Now what is e? E, you know that e minus is given as 1 minus nebula, so we can put it here. This will become 1 minus nebula to the power minus p yn. Okay, and now we'll expand this into we'll expand it using binomial's theorem. So this will become 1 plus p nebula plus p into p plus 1 nebula square plus p into p plus 1 into p plus 2 factorial 3 nebula cube and so on yn. Okay, so that we can write this series as like this. This will become yn plus p nebula yn plus p into p plus 1 by factorial 2 nebula 2yn p into p plus 1 into p plus 2 by factorial 3 nebula cube yn and so on. Okay, so this is called Newton's backward interpolation formula. Keep this in mind. We'll see example to understand this. So we have this table. For different values of x, we have values of y. We have to find the values of y at x equal to 160 and x equal to 410. So as you can see, 160 is here, so we'll use Newton's forward interpolation formula to find it, and 410 is here, so we'll use Newton's backward interpolation formula to see. First of all, what we'll have to do, we'll have to construct the difference table. So this is first, then this is second, this is third, this is fourth. Okay, let's find out. See, this is what? 13.03 minus 10.63. 10.63. So this is 2.4. This is 15.04 minus 13.03. 13.03. So this is 2.01. This is 16.81 minus 15.04. So it is 1.77. This is 18.42 minus 16.81. So this comes to 1.61. 19.9 minus 18.42. This comes to 1.48. And finally 21.27 minus 19.9. It is 1.37. Second difference, 2.01 minus 2.4. So it is minus 0.39. Okay. Then we have 1.77 minus 2.01. This is minus 0.24. Then 1.61 minus 1.77 minus 0.16. Then 1.48 minus 1.61 This is minus 0.13. Then we have 1.37 minus 1.48 minus 0.11. Now this minus this, so this will be plus, so we'll have 0.39 minus 0.24, this is 0.15. Then 0.24 minus 0.16, it will be 8.08. This is 0.03. This is 0.02. What is this? This will be minus. So this is 8 minus 5, 7. So 0.07. This is 0.05. This is 0.01. So we have values up to fourth difference. Okay. What we'll require? We'll require for 160. This 160 will lie here. So we'll have to start from here. So our difference table will be this: 2.01, 0.24, 0.08, 0.05. So I am writing the values. The first, for y equal to 13.03, the difference table will be 2.01. I am writing the values because I'll have to rub this board. Then 0.24 minus 0.24, 0.08 and minus 0.05. Okay, and for y here 410, for x equal to 410, will be using yn as this 21.27. Okay, so we'll have 1.37 first difference, second difference will be minus 0.11, then 0.02 and finally minus 0.01. Okay, so this is what we will require so that I can rub this board. Okay, so let's find out the value of y for x equal to 160. So p will be, x is 160 minus, just above that we had 150 and h is 50. So this comes to 0.2. So we have p equal to 0.2 and we know the formula. The formula is y 160, that is for x equal to 160. This will be equal to, what is the value of y for x equal to 150, just above that. So it was 13.03. 13.03, you can see the table and you can find this. The second was p delta of, that is a p into the first difference. P is 0.2 into first difference. First difference is this 2.01. Okay. Then p into p minus 1 by factorial 2. So p will be 0.2, p minus 1, that is minus. So this will become minus now, into 0.8 by factorial 2, that is 2 into this one. See, second one, minus of 0.24, that is 0.24 minus minus plus. So this is the second term. Then third term will be this 0.2 into 0.8 into p minus 2, that is 2 minus 0.2 is 1.8. So minus of 1.8 by factorial 3, that is 6, and the third difference is 0.08. Okay, and then so on. So this will become minus. Okay, so on, you can go on like this. Let's calculate this out. What is the value? So this comes to 13.03 plus 0.402. Then this one, this is 0.0192. Then this is minus so it comes to minus 0.003 3 and so on. So the values keep on decreasing. Let's see what is this. 13.03, 0.402 plus, so it roughly comes to 13.448 up to 3 decimal points. Okay. Now let's see what will be the value of y for x equal to 410. So this will be values 21.27 plus p nebula of p, first difference, that is 0.2 into 1.37, then plus p into p plus 1 by factorial 2. So this is 0.2 into 1.2 by factorial 2, second difference, that is minus 0.11. Okay. Then third one, this will be 0.2 into 1.2 into 2.2 by 6 into next value is 0.02 and so on. Let's see the values. So this comes to 21.27 plus 0.274. This will be minus, so 0.2 into 1.2 into 0.11 by 2. So this is minus 0.0132. This will be plus, so this is 0.2 into 1.2 into 2.2 into 0.02 divided by 6. So it is 0.00176 and so on. The values will be very small after this. So we have 21.27 plus 0.274 minus 0.0132 plus 0.00176. It comes to 21.533 roughly. So this is the value that we have interpolated. Okay. Let's see another problem. We have x equal to 0, 1, 2, 3, y is equal to 1, 2, 1 and 10. We have to find the polynomial that actually defines the Newton's forward interpolation formula. And we have to find the value of y at x equal to 4. So what we'll have to do, first of all, we'll construct the difference table. Let's say this is the first, this is the second, third and fourth. Okay. This is 2 minus 1, 1, 1 minus 2, minus 1, 10 minus 1, 9. Minus 1, minus 1, minus 2, 9 plus 1, 10. 10 plus 2, 12. So we have up to this one only. Why 3? Because we had 4 values. So the third value will be constant and del for y will be 0. Okay. So we have constructed the difference table. Let's say we take for x from here, x equal to 0. So what will be p? P will be x minus 0 by h, and h is 1. So I'm saying, let's say x is somewhere here for which we want to find the value. So p will be x by 1, that is x. So p is our x only. What is Newton's forward interpolation formula? Y will be, pth term will be first y 0. So this is, see, 1 plus p, that is x, into delta of y. See, first one, this is a series. So this is this into 1 plus x into x minus 1 by factorial 2 into minus 2. Then this is 12. So the third term will be x into x minus 1 into x minus 2 by factorial 3 into 12 and so on. No, not so on. This is the end of this. So this comes to 1 plus x plus 2 gone. So this will be minus x square minus x. Okay. This is minus. Then we have this term. So this is plus. So 3 into 2, 6. So this is 2. So what we get is plus 2x into x minus 1 into x minus 2. So let's write it here. This is 1 plus x minus x square plus x plus, let's see what is this, x minus 1 into x minus 2. So this will be x square minus x minus 2x plus 2. So this will be x square minus 3x plus 2 into 2x. So this is 2x cube minus 6x square plus 4x. So what do we get? We get 2x cube, this term, then x square. We have minus x square minus 6x square. So this is minus 7x square. Then for x, we have x plus x, 2x plus 4x, that is 6x plus 1. So this is the polynomial that actually defines Newton's forward interpolation formula. So if you put a value equal to x equal to 1.5, you can put the value and get the result directly. Okay. Now we have to find the value of y for x equal to 4. See, 4 is at the end of the table. Here we have to find y 4, this term. If we use that formula, it was for forward interpolation formula, so the result will have errors. So what we'll do, we'll use backward interpolation formula. So we have this for y 10, 9, 10, 12. So y4 will be equal to this 10. What will be p? P will be equal to 4 minus 3 by 1. The difference is 1. So this is 1. Okay. So 10 plus p, that is 1 into first difference. See this 9. Then second p, that is 1 into p plus 1, that is 2 into the second difference 10 by factorial 2, that is 2. Okay. Then third one will be, this is 12. So this is p, that is 1 plus into 2 into 3 by factorial 3, that is 6 into 12. Okay. So this is gone, this is gone. So what we actually get is y4 is equal to 10 plus 9. See, 10 plus 9 plus 10 plus 10, this is gone, so plus 12. So what is this? 10 plus 10, 20, 32, 9, 41. So this is 41. Okay.